Hi everyone, thanks for attending this webinar on indoor air quality. My name is Olivier Hersan, I am the CEO of Actility. So today we are going to talk about that theme of indoor air quality. We have three main reasons to present it today. First of all, why indoor? Because we spend over 90% of our time indoors, and right now I'm recording this webinar indoors. Indoor air quality has been proven to have a measurable impact on cognitive performance, and there is a real return on investment in ensuring very good air quality inside offices. And of course, if you have health problems, you're suffering from chronic respiratory problems, cardiovascular diseases, then poor IAQ is really harmful to you. So these are three major reasons to look in details at IAQ and how to improve indoor air quality. So we have just enabled the QA feature of the webinar, and you can ask your questions in writing. We will address them at the end of the presentation. First, looking a little bit at cognitive performance. In the chart here, you will see that the red square is the type of performance you can expect from a cognitive point of view under high concentration of carbon dioxide, about 1,000 ppm. It's incredibly easy to reach 1,000 ppm. You know, if you're in a small room, just one person, in just 45 minutes of occupancy of this room, you will reach 1,000 ppm. And out of curiosity, in my office, I have a CO2 meter. And after receiving, a couple of people, just having 1 hour meeting with 3 people in the office, you can reach 2,000, 2,500 ppm very, very easily. And what this chart shows is that your cognitive performance is really badly impacted, negatively impacted by high ppm, high concentration of CO2 in the room. Of course, now we're all dealing with the COVID-19 pandemic, and we all know the importance of circulating the air, opening windows indoors. The graph that you see here on this chart shows the circulation of the virus pro rata of the ventilation rate, and the ventilation rate itself can be measured, assessed very well by concentration of CO2. If you're aerating a room very often, you have windows open, then your CO2 concentration will be very close to the 400 ppm that you would find outdoors. Vice versa, if you close the window, if ventilation is not enough, then the CO2 rate will increase. It's a very, very good measure of lack of ventilation. And you can see in this graph that it is really correlated to the concentration of the virus in the air. So that's, of course, right now, a very key reason why measuring IAQ is extremely important. I think really, when you think of things more broadly, indoor air quality monitoring should really be in every classroom. There has been this study in the US in classrooms that there is really a direct impact between performance, between attendance rate in schools. And it's obvious that the school is where kids mobilize their cognitive skills the most, and they should be in optimum conditions to study. And IAQ is a very good way to measure this and make sure that they are in optimal air. Of course, with COVID-19, it's even more important. In some countries, they are putting air purification devices in the classrooms. There are some other countries that are starting massive projects to monitor indoor air quality inside the classroom. More generally, this is a very, very large market. We just covered education. I think every public building is also obviously a segment where indoor air quality should be measured and controlled. In the services, wherever you receive people, in hotels, in restaurants, theaters, cinemas, of course, shopping centers. And anytime you want to make sure you have a quality building, in the recent years, regulations of smart buildings have really focused on energy conservation. but to a large degree, they forgot about air quality. So you have many very, very modern buildings that really basically only recycle the air again and again and again. So you do have a very high energy performance, but from a health point of view and performance point of view, it's very poor, and the indoor air quality is very poor. So right now you see very large owners of real estate that are starting to monitor this factor in a sort of half panic, because the value of these towers, the value of these buildings could obviously go down if people realize that, yeah, they're all shiny and modern, but for people, they're simply not good. So all of this opens a very big market, and all these sensors need to be connected. So today we will be discussing LoRaWAN, our partners that will be presenting their solutions right after this, or using LoRaWAN as the connectivity technology. So why is that? I'll be brief. This is not a webinar on LoRaWAN, but obviously the key reason is that as buildings are not equipped, you need to install the sensors in a retrofit. You don't want wires. Wires is an absolute no-go in any retrofit operation. So you want very reliable wireless network. LoRaWAN provides this. I will explain in the next slide why it is so robust. The main qualities of LoRaWAN, obviously long range, sub-gigahertz spectrum that goes across walls quite well, but also collaboration across antennas. More on this in a minute. But also it's an open standard. So if you start to install a LoRaWAN infrastructure in a building for indoor air quality, you want to be able to reuse that infrastructure to do more things. You might want to monitor door opening and closing, monitor occupancy, motion, motion sensors, and so on. There is a very rich ecosystem in LoRaWAN devices. You can go to our market.thinkpark.com. You will see over 1,500 devices there. So obviously it makes the networks, it's easy to amortize network over more use case. There is a massive ecosystem around LoRaWAN. Just one more detail before I give the floor to our speakers today. This is a quick illustration of macro diversity. Unlike other technologies such as mesh, some of you might be familiar with Zigbee, LoRaWAN ensures that all antennas collaborate. So to ensure a very good quality of coverage with LoRa, it's very, very easy. Any place you have little patchy coverage, not good enough, you just add an antenna, the network immediately reorganizes, and there is no hopping, from device to device. This is not mesh. You go straight to the infrastructure, and actually the LoRaWAN infrastructure is leveraging the information from all antennas. So if you get coverage from 2 antennas in a given room, you will not lose data unless both antennas lose the packet. And because of this, you can get very high level of quality of service with LoRaWAN in buildings. And it's obviously the technology of choice for indoor air quality. I will be leaving the floor to our partners. Before this, why Actility in this webinar? We are one of the leading, probably the leading company deploying LoRaWAN worldwide. We serve public operators. Many networks have deployed nationwide, Switzerland, France, Holland, many others. We serve also private networks, both served from a hosted infrastructure for offices, for retail type of use case, or deployed on-premise for industrial, for all sensitive military government sites. This is fully on-prem. We also enable roaming between public and private networks. We serve OEMs via our ThinkPark embedded program. And we have a very, very vast deployed ecosystem. We have over 35,000 gateways that are professionally maintained, over 1.5 million devices that are connected to the network and monitored. So that makes us a very experienced partner for your indoor air quality project. With this, I want to introduce our partners who are all specialists of the topic. You have Mireille Ramey, who is the technical and digital manager at Veolia for their air expertise cluster. Air quality is a very, very big focus at Veolia, this giant group that Mireille will present. We have Olivier Martimore, the CEO at NanoSense, who is really an expert of sensing in this area. Pierre-Emmanuel Dubois, the international channel manager at Birdz. Birdz is deploying massive IoT networks for many applications. One of the biggest networks probably for water metering, and also large experience for in-building connectivity and in-building sensing. So he will bring their experience. And we have also Leonardo Vasquez, the COO at Accenova, also with great indoor air quality expertise. I hope you will enjoy it and find it very interesting and informative. Thanks again.
Thank you, Olivier. First of all, I want to thank you very much, Actility, for the invitation to the webinar to have the opportunity to present one of our solutions. I will introduce myself. My name is Leonardo Vasquez, CIO of Accenova, company dedicated to the creation of IoT solutions, based in Argentina and serving companies from all over the world. Today, I will present Accenova QR, a solution created to manage ventilation in indoor places to fight COVID transmission. There are two ways of COVID transmission, droplets and aerosols. A person spreads droplets when talks or cough, and droplets only remain seconds in the air. Aerosols instead are spread with the breath and are formed by tiny particles less than 5 microns that could remain in the air by hours. The danger is, if the ventilation is not enough, they could begin to concentrate and increase the risk of contagion. With your reading, we exhale aerosols and carbon dioxide. Therefore, the measurement of carbon dioxide concentration is an indirect way of measuring the concentration of aerosols. Carbon dioxide measurement is an economical system that allows us to know if the chosen ventilation system is sufficient or not. There are many practitioner institutions that study the problem. To resume, in general, most agree that to contain the risk of contagion, carbon dioxide concentration on indoor places could go not over 2 times carbon dioxide concentration open air. This is more or less 150 parts per minute. The solution consists of carbon dioxide sensor in each room. We send data to a center system in the cloud. This data is deployed to a monitoring center, of course, depends on the customers, to a mobile app, and in a cloud management and reporting software that allow to do settings and generate analytics. Over this base solution, we can add display, integrate information with public information system and other platforms. The architecture is based on a LoRaWAN network. In each building, where are the spaces to be managed, is installed a gateway or a Pico gateway. Then carbon dioxide devices are installed in every space to be measured. This is repeated in each building where the solution is installed. All these gateways communicate with Actility SyncPark network server that manages the entire LoRaWAN network. Finally, the data is integrated with the server in the Accenova cloud, and then with the front-end systems. Sensing devices are central part of the solution. They are designed and manufactured by Accenova. They are headless, which means that they don't have any information of the device. This is a criteria design looking very low maintenance. There are devices of world-class carbon dioxide sensor. There are sensing devices supplied by alternate current and other with battery. In addition to these devices, the solution can be complemented with a smart thermostat or actuator devices or LoRaWAN that can allow automatic ventilation management. The idea of Accenova QR is to give the customer a tool to quickly and easily implement interior ventilation management process to minimize the risk of contagion of COVID. The process is, you do carbon dioxide measurement, then you have real-time data, generate alarms and events, then you get the ability to act on time. But as soon as you have historical data, you can analyze historical data and try to associate with the behaviors and redefine protocols. If necessary, other actions are taken to ensure the proper ventilation, and the process never ends. Main use cases are clear. Offices or indoor places are few, or indoor places where few people work together. Public attention point, classrooms, hotels, restaurants, This is a new solution we are receiving, but we are receiving a lot of requests. We are working with several educational institutions in Argentina. We are currently working with a government agency to cover all the schools in the large district. We are working with clients in Chile and Uruguay. We can begin to work with customers in Italy, and the list continues. Okay, I will switch to the demo. Okay, let me show you one of the front end of the systems. Here is a gauge with the actual value of carbon dioxide. We have here the red zone, the green zone, the yellow zone, and the red zone. The green zone is you don't know, go over 600 per million of carbon dioxide. Then you have a yellow zone between 600 at 850, and then over 850 is red zone. Then that means that you need to try to remain always below this red zone. And you can hear, this is the trend, the last 3 hours, that allows you to see if you see something here, you take some action to do ventilation, if the pattern is changing or not. And in other way, you can see the historical data. This is the last 7 years. You can see here, this is an attention public point. They begin to attend the public, and then they close. And it's interesting to see we are working with the system from several days, and then they were having here some problems. Then we analyze what are the problems, what are the behavior to change, the action to take, and then now we have the ventilation under control. Well, Actility QR have many advantages. It's a solution quick to set up, easy to use, and near zero maintenance. This is a solution. This solution is designed to be a tool to support the process of ventilation management, looking to reduce COVID contagions in indoor places. And Actility QR is using the minimal resources possible to do that. You can extend the solution adding ventilation automation, where it's simple, functional, low cost, but extensible. We really hope that our solution can help many people. Well, we're right to the end. Thank you for the attention. Question welcome. Now I will let you with the next speaker, Mirel. Mirel, the mic is yours.
Thank you, Leonardo, for the very interesting presentation. I can't agree more on the importance of the ventilation in today's construction, as well as the CO2 and pollution monitoring for guaranteeing a good indoor quality. That's how Veolia was able to ensure a healthy environment for the students of Florence schools through collaboration with multidisciplinary partners. I may present myself first. So, Mirai Rahme from Veolia. I'm a technical and digital manager of the Air Expertise Cluster. With Olivier, CEO of NanoSense, and Pierre-Emmanuel, International Channel Manager at Birdz, we will present you how we did it. I will start by presenting Veolia's air quality solution, which were developed in order to address the urgent need for a safe indoor environment, in addition to the growing regulatory challenge. These offers are based on 3 service components: air quality, air performance, and air human. Air control helps us to make the invisible visible. It's based on reliable measurement devices qualified by well-known third parties to monitor continuously and in real time the main parameters of air quality, including CO2 and PM. The key performance indicators adapted for each profile are communicated to the occupant, the client, and the building operator. Thus, we can identify the main source of pollution and therefore recommend the appropriate solutions. In order to achieve and maintain a healthy environment, air performance requires an engagement and commitment to results. It begins by evaluating the existing ventilation system, optimizing their operation, or if none exists, we can install, manage, and operate innovative and efficient ventilation systems. Of course, to track the performance of installation, we rely on continuous and real-time monitoring, so it means implementing air control first. Air Human is here to involve all stakeholders because we, the occupant, employees, landlords, and building operators, all have a role to play to ensure a good environment. Training, web, and mobile application are included in the offer to promote interaction and capture users' perception. These offers are adapted to different types of buildings, such as offices, hospitals, shopping centers, hotels, nursing homes, etc. Here's an example where we apply these three offers in 2 schools at LoRaWAN City. As you know, school air quality is a major health concern for both municipalities and parents, especially in the light of the current COVID-19 pandemic. There were many challenges to overcome, but the main are to guarantee a good indoor air quality in unventilated schools, to set up the solution without disruption to teaching, and to communicate accessible information about air quality and the solution for students. After conducting an audit to evaluate the global air quality of schools, including formaldehyde, benzene, bacteria level, and other VOCs and pollutants, we installed the indoor air quality probes that measure several parameters, including CO2, PM, and total VOC. We installed the mechanical ventilation with filtration system that is demanded control ventilation using the real-time pollution level transmitted by the monitors. It's worth noting that our installation also meets the energy performance challenge. All data collected via LoRaWAN network, processed and transmitted into usable and accessible information, then communicated to the client with transparency through all dashboards. In addition, we used educational tools to explain the project and the value of air quality to teachers and students. Here are some results showing how this solution creates a healthy environment for the students. The box plot of daily CO2 concentration is shown in Figure 1. As we can see, the mean CO2 level exceeded all the time the 1000 ppm threshold. With a majority of the time exceeding the 1500 ppm. As compared to the 800 ppm recommended today, this is nearly double. The second picture showed the daily concentration with Veolia's air performance solution, where we can notice that 1000 ppm threshold was guaranteed all the time. If you are familiar with the IAQ index of the French regulation, our solution helps to attain IAQ 0, which means a well-ventilated room. For information, IAQ is a CO2-based index established to evaluate the air renewable level in a classroom. LoRaWAN schools were one of the rare schools that implement CO2 monitoring before the pandemic. As we saw earlier in the previous presentations, the monitoring of air quality is more critical today than ever. There is sufficient evidence of airborne transmission of SARS-CoV-2 with a risk level dependent on multiple factors, like volume of the room, occupancy rate, number of contaminated person, the level of ventilation, and the inability to wear a mask, like in school cafeterias, for example. That's why the French government has recently recommended CO2 monitoring in those spaces as a tool for improving window airing and avoiding the accumulation of the virus. In this context, Veolia launched the latest, our new offer, comprehensive monitoring and warning system that offers this type of solution, which is air control COVID. Our offer is based on reliable devices with LED lightning indicators, real-time monitoring, and alerting via SMS and email, periodic reporting, as well as data visualization via web responsive application. Our innovative air quality solutions are based on Internet of Things, so based on a complex digital process starting from material selection, installation, and configuration, going through data collecting, storing, processing, and analyzing in order to follow up the air quality and suggest the suitable solutions. Every step in this value chain should be held taking into account several criteria, like the monitors should be reliable, precise, and adaptive to the client need, building type, and we should take into account the installation constraints. As well as the network coverage is an important question to pose while choosing the connectivity. The on-site installation should be done according to a well-studied sampling strategy. And since the data is an essential element of the solution, it should be acquired, stored, processed in a continuous manner to help the indoor air quality experts and building operators to do their job. It's a multidisciplinary environment. That's why, in order to implement the air quality solution and guarantee a good indoor air quality, Veolia collaborates with different partners, such as NanoSense for the indoor air quality monitors and Birdz for data collection and integration. I will finish here to let them present their solution to you. And for more information, please visit our website, airquality.veolia.com, and I will hand over to Olivier Martimore, the CEO of NanoSense. Thank you for your attention.
Thank you, Mireille. I'm going to present myself. I'm Olivier Martimore from NanoSense in France, and I'm going to show you what we are doing in our company, which is very dedicated to air quality. We do indoor mainly and some outdoor probes. And on the left, you can see our main product, which is the E4000NG, which has CO2, VOC, temperature, humidity, and have some temperature control, ventilation control, and over-the-cable update firmware. On the middle, you have the particle probe, P4000NG. And on the right side, this is a flush mount product. Others were wall mounted. And with 12 measurements on board, and also, of course, the control algorithm on board. All of them, as you can see, have many protocols. And this is recap here, where multi-sensors, multi-protocol, multi-criteria of remediation, of course, and they are all designed for 10 years lifespan. This is required by KNX, by the way. And this is really designed for maintainability. So most of the sensors are plug and play. We can even identify, in case of failure, the part that has a failure with a built-in test. And the MTBF for this probe on the right is 42 years. This is, of course, designed for lifecycle cost. As you can see on the bottom, it is quite modular, so you can plug a radio module, which can be either an Ocean or LoRa. This is exactly the same kind of module. And of course, for the LoRa, you can see the data matrix that you can scan as well as join LED. So this probe, or those probes, are quite known, I would say, because we won the 2 Air Lab challenge of the macro sensors challenge in 18 and 19. They were no in 20. And as you can see, the result is that we are quite balanced between relevance, cost, ergonomy, accuracy, and so on. The choice of the radio that we had on for our probes is that we decide not to use the Wi-Fi because it's forbidden in a French school, and also it's not as reliable as that we would like. So of course we have an option for building automation, and even if we, for some monitoring, give up this solution for long range, and we decide not to use the Sigfox because there is no downlink and not capability of a private network. And we of course have the LoRa, which is also allowed in French schools. It has been validated by various POC, and the big advantage is that we can use a private network, and if you want to speed up the transmission rate. And of course, it requires 1 gateway per building instead of many for a nation. And here you can see an architecture of one of our POC. So this is in a school. On the left, you have the 2 probes that you have seen previously with CO2, VOC, temperature, humidity, and particles. And as you can see, one is controlling a VAV, a variable air volume register, to control the ventilation. And outdoor, we have a probe also that we do, which is also LoRa. And I want especially to mention that air quality probe is measured, the air quality, is measured every 5 minutes and sent every 10 minutes in a telegram where we contain the 4 measurements. So even if this is an architecture for operated LoRaWAN network, we are allowed to have a higher rate. That's what is allowed in the transmission rate in terms of measurement. The drawback here is that we don't have any OTA because we have very few downlink. So update of firmware is impossible, which is not the case of the next architecture here, where we use a private LoRaWAN network, where we are allowed to increase the speed of the transmission and also benefit from the OTA, which is brand new now in the LoRa Alliance. The only drawback is that it requires an internet access or a 4G router, which is not always easy to get the internet access. Here I would like to highlight the interest of monitoring indoor air quality. On the left, you see the outdoor particles, which have been quite high recently, outdoor, but indoor, it goes through the filters, as you can see. Even if it is filtered, it's not 100% removed. Some pass through, and this is PM2.5 here. So this is just interesting to know how a building reacts and the ventilation system reacts to the outdoor air. On the right side, you can see in the center the VOC that increased during the night because this building, they shut down the ventilation during the night. So materials are emitting and the VOC goes up. And then when the HVAC returns to on in the morning, it is evacuated and it is normal and acceptable in green. What we have on the bottom is the CO2, especially during the pandemic here. where we have a higher ventilation rate to try to reach an acceptable level of CO2, which is safe. But as you can see here, the peak are of course based on occupancy, but as you can see, we have the humidity which is too dry, always because in winters, when you heat the outdoor air, that dry it because it is a relative humidity. So, to make a recap, the goals of most of the POCs that we have done were made in schools, and to guarantee a good air quality and to take into account the feedback of the educational community, based especially on what we can show. Otherwise, because there is no feeling of air quality, you don't smell it really, so it's not easy to appreciate it and to give feedback if you don't have any way of showing the air quality. So that also allow to ensure good monitoring and acquire good knowledge for mass deployment. So the return of experience is that we had to set up the CO2 level at 800 ppm instead of 1000, which is the regular one for the COVID. And this is why it is important to have the OTC or OTA I was mentioning as well. And for building where there is no HVAC, it has been shown that it is very important to have a very dynamic LED to open the window just in time and to close it, especially in winter time when it's cold, in appropriate time. So it has to be quite dynamic, and probes that are battery powered are not doesn't have such high rate of measurement. Also, very important point is that LoRa, even in operated LoRa, we can benefit from the downlink. Sorry, the downlink provides a change. We can change the measurement rate, so that means that we can slow it down during the night and increase it during the occupancy time, which is good to see also how it reacts, and especially for when opening the windows, if the CO2 is evacuated rapidly or not, you need a high rate of measurement. So thank you. And now I give the hand to Pierre-Emmanuel.
Thank you very much, Olivier. So my name is Pierre-Emmanuel Dubois. I work as International Business Development Manager at Birdz. So I will now present you the data integration and analysis from Birdz. So just a few words about Birdz. Birdz is the IoT Digital Competence Center of Veolia. So we provide digital services to the Veolia group and outside of the group. We have numerous municipalities as direct clients. We are a digital service provider for industrial environmental IoT with more than 20 years of expertise, so long before it was called IoT. We operate more than 3.6 million connected devices every day through Birdz Legacy, LoRaWAN, or Sigfox. Our domain of expertise is quite large. We were initially a pure player in water, but we have now been boosting our market penetration and promotion in waste, energy, smart building, and obviously indoor air quality. We help our customers measure their consumption so they can understand and reduce their impact in terms of environmental footprint. So now moving to the challenges of the IoT jungle. Most complex IoT projects involve various use cases, various sensors, various IoT protocols, and sometimes even various standards, more or less mature, various offering and systems, all of which are not always interoperable. There is a huge need indeed for technical and business expertise to master all of that, which are two expertise sometimes very difficult to merge. And in order to master this complexity, it is quite critical to be accompanied by business experts. And that's what exactly does Birdz. We help simplify the complexity of integration, rollout, and operation of IoT projects. So how do we do that? Basically through an hardware-less offering, an IoT data platform for environmental smart solutions. So Birdz has launched in 2020 to the market an IoT data platform offering in order to simplify the complexity of IoT integration and interoperability, and to help our customers easily deploy all types of environmental IoT projects, sometimes very complex. So this offering comes in three complementary bricks. First, the IoT platform itself, called IAQIDAQ, which is a full software as a service platform, agnostic of all use cases, devices, IoT connectivity protocols, and software applications. The second brick, the left-hand side, is the IoT Architect, which is an online dynamic IoT catalog that gathers all devices, connectivity protocols, and software applications available per country for a given project. It helps you basically design a high-level architecture for your IoT project according to your project requirements. And the last brick on the right-hand side is the IoT Assist. So that's the human engineering and business support to design and drive the development of a project. Let's focus now on the IoT data platform itself, the IoT Drive. While defining, deploying, and managing environmental IoT projects can sometimes be very complex, since one can face immaturity and variety of communication technologies, lack of interoperability, as I was saying, and standardization of data protocols. And in an IoT project, sensors can be connected to one or multiple sources of IoT connectivities, ERP or billing systems, which creates eventually tens and sometimes hundreds of combinations. With the IoT platform, all of these combinations are supported into one unified platform. So the IoT Drive is the link between, first, the complex world of IoT sensors and connectivity, and second, the environmental business use cases on the other hand. Whatever the IoT sensor or connectivity network, the IoT Drive platform unifies the IoT data, it cleans it, it formats it into qualified data flows, which feed your analytics and business applications. In other words, like we used to say, the IoT Drive is the Google translator of the IoT complexity. One word in terms of connectivity. The IoT platform does not manage a network management system itself. We rather stand by operators that have this offering, and we connect these operators to the IoT platform. So the IoT platform is not, I would say, a IoT core network-based platform, but it connects to different telco core networks through connectors. Amongst the first IoT Drive-based projects launched, Birdz has worked with Veolia Germany on the pilot project of Cotton. The objective of this project was to integrate data of three different use cases. So first, water metering, second, water leak detection, and third, waste container filling sensors. All of these sensors coming from three different manufacturers. I believe Kodea from Czech Republic, Tekelec from the UK, and Seba from the US. And all of them performed on NB-IoT connectivity and LoRaWAN. And as a result, the full project perimeter was So development, management, and delivery of dashboard has been performed in a few weeks' time, and all of the 3 data flows have been integrated into one unified hub. Coming back to our initial use cases, around, so as Mireille was mentioning it in the beginning of the presentation, so the use case around indoor air quality in a school in the city of Rancy. So Birdz has participated in this project, performing the data collection and integration, and supplied also the IoT connectivity needed to collect all the data. And if we succeeded in this Rancy project, that's because we have mixed business expertise from different parties. First, the supply of IoT sensors, which was performed by NanoSense. Second, the installation of the IAQ indoor air quality probes and the ventilation systems, as well as the maintenance, which was supplied by Veolia Energy. Birdz has supplied the data integration and collection and the connectivity through LoRaWAN, private LoRaWAN connectivity. And lastly, Office, through their IAQ experts, have performed an audit raising awareness amongst the occupants. Well, so thank you all for your participation to this webinar. I believe we will now move to the Q&A session. Thank you.
Okay, this is Olivier again. So we have been receiving lots of questions. Okay, the first one relates to the sensors themselves. Oh, an interesting one. How many square meters can you cover with one sensor? I assume the CO2 sensor. So when you measure high ppm measurements, you know, how large is the room where you could place this sensor? But I guess this is probably for NanoSense.
Okay. Okay. As a matter of fact, the surface which is covered depends on the ventilation system. It can be a small room or a large room, but if it's a large room with different ventilation inlet, it could that are driven separately. It's in such case needed to have as many sensors as we have inlet, control inlet, separate control inlet. I don't understand the question regarding the 480 ppm because outdoor is around 400, so 480 is quite low. But this is the answer. So it could be small to large. There is no rules of surface, by the way. But one rule is that you have to install the probe at least at 2 meters from people, because when you breathe out, you generate a lot of CO2. So if we have to have the average of the room and not what you breathe out. So that's an important point.
Okay. Thanks, Olivier. Several questions for Leonardo. I will bundle them. So there is a question on CO2 values, the thresholds that you use, 600, 850, 2000 ppm. Are they based on some kind of official recommendation, or is it your own experience? And are these values related to specific settings, you know, like specifics for schools, specific for retail, specific for offices? First question, and second for Leonardo is any display for the CO2 sensors?
Well, for the fixed one, the values, really, we have a lot of different studies of different entities around the world. There are different recommendations, and normally we discuss it with every customer and then define the range. This range that I show is the range that we set with the customer based on all information that we share with them. And the second one is regarding the display. The sensor itself does not have any kind of display, but we put it in, depending the case, depending with what we need to show. We used to put display in the a cloud connector display that shows information, or even sonic alarm to do the feedback to the people.
Okay, thanks, Leonardo. For the classroom example, the question is the scale, how many classrooms have been equipped, and there is also sort of rule of thumb for a budget for a school. I guess probably a budget per classroom.
Yes, it's, you can hear me?
Yes, yes.
So we equipped more than 30 classrooms in both schools, and the budget is about, we prefer to talk about the budget per student, so it's about €5.50 per student, which makes almost 20,000 per school per year.
Okay.
And this budget is the cost of to guarantee the air quality. So Veolia is engaged on the results. It's not just the mean just the installation. It's about the result.
Okay. There is Mireille, another question for Veolia. Actually, two. How big you think the IAQ market is going to be for Veolia? Do you already see signs for it to become a new standard for office buildings? Like by default, your customers will like to retrofit their buildings with IAQ monitoring. And what's your feeling about municipalities? You know, there is the private market with buildings and the municipalities. Do you feel they're ready and the moment is now?
Of course, it's the moment for indoor air quality monitoring, especially after the COVID pandemic and the recommendation of the government to follow the CO2 concentration. It started in the schools, but today we're hearing this recommendation for all places that receive public. So I don't know. I cannot answer for the market. It's more the commercial team that can answer this question. But we are working with all the business units around the world to provide them with efficient, efficient solution that they can propose them to their clients.
Okay. Another one came while you were speaking on recommendation. Assume an air quality alert is triggered, so some room has turned red. What is the recommendation to end users? Should they leave the room until it gets green again?
Yeah, please.
Yeah, and because you might get pushback from the local operations, you know, if it disrupts, you know, people leave the room or it creates a sense of panic. In your experience, how is the best practice to handle alerts, IAQ alerts to not panic users?
There is two different use cases. Today, the direct alert is here to help the occupant to act, which means opening the windows like in a school. But usually the alerts are sent to the operation team in order to make a preventive maintenance. So if it's urgent action, he can come and repair the problem, and or increase the ventilation rate. But what we recommend is to direct control the ventilation system, the airflow rate, in order to ensure the health level of pollutant concentration. But
okay.
So in COVID case, the alert is for the occupant to open the windows in today urgent pandemic case, but it's not a pertinent solution for long time period.
Okay, thanks a lot. Questions keep flowing for you while you have the floor. First question that is, do you provide detectors for ammonia to check air quality when there are factories around? And the second question is on budget. Your budget of 5.5 euro per student, did it include the hardware?
For the first question about ammonia sensor, we have solution for industry and the air quality around factories, but I'm not sure if we provide this type of pollution. I should ask the team that work on this and on this type of subject. But we have solutions. So the person, I think it's Amadou, he can send me an email and I will put him in contact with the right person. Concerning the budget is 5.5 euro per student, which is the total. Yes, of course, it's the total budget of the project, which which I think there is about 100,000 euro of hardware. It's about the CapEx, the installation, the materials. There were about 100,000 euro.
Okay. Question for NanoSense, a technical one. I guess you have a 10 volt, 110 volt output to control actuators. Question is it programmable?
Okay, so the questions come from someone who is very, very, who knows the product, because EP5000, it's a brand new product which is going to be released very soon. So this product is settable all by the smartphone via NFC, and the 110 volt output is a PI, proportional and integral, and can be set to, I would say, threshold levels on CO2, VOC, and PM, or you can choose either physiological effects with set points which are like productivity, health, and so on. So there is many ways to control, to set up the 010 volts to control the VAV.
Okay, thank you. A couple of questions on LoRaWAN itself, so the network. There was one for me, so I will address it directly. What about using open source for LoRaWAN versus commercial solutions? So there, I think open source is okay to start, if you do a small POC. And the problem with open source is when it scales, there are several issues. The first one is that LoRaWAN is actually a very sophisticated protocol because the antennas collaborate. You have an algorithm called adaptive data rate, which controls power, it controls number of times to repeat a packet, it controls the channels that are active, power as well, speed of communication. And all of this needs to be optimized in a way that is very, very subtle. I can tell you for us, we worked over 3 years on optimizing this. And this is what allows the solution to scale to thousands of sensors and make sure you have very good quality. So what we observe in many of our customers is that they started with open source, and when the project goes commercial, they switch to professional solutions from us, from Birdz, from other players. The problem is the switch is very, very costly. So to avoid this, we have created what's called ThinkPark Community, which allows you to start for free, but on a commercial platform. So when you want to scale and switch to something that is really, you need zero redundancy, you need scale, you need quality of service, and so on, you don't need to reprogram everything. Because the problem is when you switch the network infrastructure, usually you need to change your application, you need to reprogram sensors. It's a big nightmare. So that's to address this question. So I really advise starting with a professional solution from day one, and professional does not mean expensive. It can even be free. If you type ThinkPark Community on Google, you will find the free platform. Then there was a question on benefits of LoRaWAN compared to narrowband IoT and Cat-M. Clearly, there are two. One is power consumption. There is about 1 to 20 ratio in the power consumption between LTE-M and LoRaWAN, and about 1 to 10 between LTE-M and narrowband IoT. So this is absolutely huge. So I think all the sensor manufacturers here in the room, they know exactly why they've done LoRaWAN. Another difference that is a bit more subtle is the peak current. The peak current that is used for LTE-M is about 10 times the peak current of LoRaWAN, and that has a very, very big impact on battery lifetime. You actually divide the capacity of a battery by 2 if you use LTE-M compared to LoRaWAN. So that's why all these sensors, they are LoRaWAN. There was one more question, I think, on LoRaWAN. I'm just skipping. Oh yeah, there was a question to Mireille, so maybe I can direct it to Mireille. Maybe I answered it a little bit, but can you clarify why you use LoRaWAN as opposed to Wi-Fi?
So in addition, of course, of what you already said, Olivier, it's because LoRaWAN is simple to implement, and Wi-Fi in France and the schools, it's prohibited, it's forbidden. So we cannot use Wi-Fi. And also in some offices and companies, there is a question about the security of the Wi-Fi. So we prefer the LoRaWAN in these cases.
Okay, thanks a lot. I'm just checking that I didn't forget any question. There was a question on tools to use for site surveys. This was to Olivier Mortimer. I can give a quick answer on our side as well. We just use trackers, which send a signal, and then it's analyzed in the backend. But I don't know what you do, Olivier.
As a matter of fact, I don't understand exactly the question. If it's a survey of the LoRa coverage, or if it's a survey of the air quality before installing a remediation system. So.
I didn't think of this angle. So yeah, I took it from LoRa, but maybe it was from air quality. And
I took it on the air quality side, okay. Of course. So in some particular case, and we had this for Paris, for instance, where we install some schools, Paris City has a department in charge of measuring air quality with very professional devices. And what they do, they come first before we install anything to have a T0. Then after installation, they come with a T1. And then when it is totally adjusted and well performing, there is a T2 to show the improvement based on professional and official devices. But I don't know exactly what the question is related to.
So it was indeed for LoRa coverage. So, for LoRa coverage, I know on our side, people go around with trackers this is, I don't know if you see, this is a small one, you have bigger ones. It is sending a calibrated signal. And the network is measuring the signal-to-noise ratio, which is key in LoRa. You know, in LoRa, it's really the signal-to-noise ratio that's important. And based on the location and signal-to-noise ratio, we build maps, you know, color maps of where it's well covered, not covered. We also provide statistics on packet error rate. And as Mireille was saying, LoRa makes it very, very easy. If you have an area in your building that's red, you know, you have packet error rate that's not so good, you get a signal-to-noise ratio that causes the sensor to go to spreading factor 12, so it's consuming more power. You really just need to add a small antenna locally, and the network server will readjust transmissions automatically. So you don't need to do any network planning, really. You just need to do site surveys from time to time, or even just take into account feedback from users that a certain sensor in the packet error rate statistics, this is the most important, you know, to measure the packet error rate of a sensor. If it's low, you need to, if it's high, you get lots of errors. You need to reinforce the network locally. And you can do so by very, very inexpensive picocells. I don't have one around, but really it's, you know, very small boxes like a Wi-Fi relay. And that allows you to reinforce coverage in this area. A question to Mireille, is there any voice commands to control air quality devices?
What we mean by voice command, it's like...
Yeah, I think it would be more for residential, you know, in maybe, and this is for residential use, you get Alexa type of commands, but I think in your market, probably not.
No, it's not. There's no need for the occupant of the building to control air quality directly.
And I guess if you would do this for schools, it would become a nice game for students.
Exactly.
The question just before, what is the range covered by CO2 sensors? Can they be used for outdoor monitoring? I think it's slightly different markets, but you're the expert. I don't know whoever wants to take the question between outdoor and indoor air quality monitoring, the difference.
I will start a part of this question, and I leave Olivier because he is an expert on the sensors. We can measure the CO2 outdoor, but there's no huge interest because usually outdoors is almost about 400 ppm, except in some areas. And if the same sensor can measure indoor and outdoor, I let Olivier answer this question.
Yeah, the outdoor pollutant is not CO2. In some urban area with heavy traffic, then the background of CO2 can rise to maybe 500 ppm, which is anyway used as a, quote, fresh air to ventilate your building anyway. So you have to consider it as good as a good thing because you have no way to do differently. But the probe that we do for outdoor is mainly related to particles. As you know, just in France, PM2.5 is killing more than about 70,000 people per year. So about the COVID, by the way. So this is a real concern. Particle is the main killer. Then after that, you have NOx, ozone, but CO2 is not really a concern. It can be used in the past. It was used in the past as to indicate the global pollution, because when you have combustion, you have NOx and so on, and particles, but you have also CO2. So an increase of the background of CO2 generally show that behind that you have particles and other pollutants, but it's not very helpful because we have dedicated measurements of other pollutants.
Yeah, now you have much more precise sensors for precisely the particles.
Yeah.
At low cost. And I think now it's the last question. Well, actually, I have one about duration of sensors. I know early on the chemical sensors, they had the limited durability, which means maintenance implied replacing sensors. In the new state of the art, what is the lifetime for chemical sensors? And my second question would be, what is the state of the art in power consumption for CO2? Because initially it was very high with infrared use.
Yeah, okay. So that's right. Now you have for some species like NOx, ozone, that we call MOX sensor, metal oxide sensor, and metal oxide sensor are now so small that the energy consumption allows them to almost work on batteries. But it is, of course, pulsed. It's not power all the time. And the lifespan is over 10 years compared with the electrochemical sensor, where the chemical compound was drying over the time, and the lifespan was few years, even sometimes 1 year. So 10 years is a good base for such kind of sensor, which is the same for CO2 and the same for particles. So this is quite consistent, even if there is some sensors that overpass 15 years of lifespan, sorry. So regarding the CO2, this is an optical absorption process on 4.2 micrometer. And the energy comes especially from the source. In the past, the sensor had a kind of a bulb light, which was consuming a lot, even if pulsed. And now you have technology with special LEDs emitting in such 4.2 frequency that allow very good effectiveness. And a sensor, a CO2 sensor, can run about 10 years. Of course, it is pulsed. It's not continuous measurement, but 10 years can be reached with the battery now. And with energy harvesting, even at a higher rate.
Okay, well, great progress. There has been really great progress.
Not in PM yet. Not in PM yet. That's the point. We are all waiting low consumption particle sensors. It's coming. It's coming.
Okay, thanks a lot, Olivier. It was very interesting. Follow-up questions, and then I think we can close all for Mireille. I think that again, maximum volume or dimensions of a room that will be covered by CO2 sensors. Like if you have a university conference room or warehouse, like really big rooms, what's the rule of thumb for CO2 sensor dimensioning? And question also on calibration time for VOC and CO2.
So for the position of the CO2 sensor in a room, it depends on different parameters. The objective of this measurement is to represent the presence of the occupant. So if we have 1, 2, or 10 person in the room, this CO2 can detect the number, not directly the number, but the CO2 level in the breathing zone. So the breathing zone is should be determined where the occupant should stay the most in this place. And it is also dependent on the airflow rate and the air distribution in the room. And of course, this is in the ideal case. We can choose the best place to put the sensor is in the middle of the room, which is not always almost always not possible to install it there. So the choice, it should be far from any windows or any opening door, and in almost on 1 meter, 1.1 or 1.3 meters. So it will be on the same level of the breathing level of the occupant. And when we have a huge volume, and if we need to control the ventilation system using the CO2 level, it's better sometimes to have more than one sensor in huge places. Concerning the calibration of VOC and CO2 sensor, so as we are a client for the manufacturers, sensor manufacturer, so what we ask is a pre-calibrated device, which is before we install it is calibrated, and should be without drift along the time. So there is, for the CO2, there is auto calibration process that is based on the background concentration, the minimum concentration of the place. But I will let Olivier also answer this question about the calibration, because they already do that for their devices.
Yeah. As you know, buildings have to have, for the health of the building, a minimum of ventilation, even when it's unoccupied. And this is the opportunity for the sensor to see the outdoor level of CO2, even if it's not effectively 400, but the lowest value in our case, it's settable, of course, but it is based on the lowest you can see on 2 weeks, on 15 days. And then this is recorded, then applied. And so this is an auto calibration, which is called ABC, automatic baseline calibration. And we do the same for CO2 for one particular reason, is that this sensor is not for lab. It is used for ventilation purpose. And if we don't want to ventilate 24 hours a day for nothing, so we consider the outdoor VOC level as the best we can get, and that is used as a baseline for the VOC concentration as well, calibration as well.
Okay, thanks a lot. We'll close there. Just a quick question on site survey tools. Is that available to Actility customers? Yes, even on the free side, on the LoRa product that is called ThinkPark Enterprise, and of course we have ThinkPark Wireless for operators like Orange and Birdz. But the tool is there by default. There is a page for site surveys, and you get the tool by default. Thanks a lot. It's been an amazing webinar. It's very rare that we get so many participants till the very end and so many questions. So I think it's a sign of very big interest around air quality. I want to thank all the participants. Really great. It was great to have so many experts in the same room on this really interesting subject. So again, thanks everyone, and we can get back to normal activities. Bye.
Thank you. Bye-bye.